quitar eh, mi imagen para que yo pueda seguir hablando y me escuchen.
Sí, estás con tu imagen ahí, si quieres poder hablar.
Perfecto, gracias. Okay.
Ya está. Espérate un momento. Yo quería quedarme fuera de eso. ¿Quieres hablar un poco con ellos?
Sí.
Si quieres puedes hablar, ya te ven.
Ok. Bueno. Okay. Thank you for attending this workshop. My name is Angelica Guzman Ponce. I'm a postdoctoral research at Universidad Jaume I, and today I would like to present the mini course, An Introduction to KEEL for Machine Learning. Well, broadly, the structure of this workshop is composed by firstly an introduction where the KDD process and the background on KEEL software is given, followed by some items about interface. Then the data management is described to continue with the experiment design. After that, the KEEL models are described. To finalize this workshop, we'll use the KDD process in KEEL with a data set example. Well, about the introduction, the KDD process has served to unit research from areas in principle described as artificial intelligence, statistics, visualization techniques, mathematics, or databases. In the research for efficient techniques and then help to find the potential knowledge that is immersed in the large volumes of data stored by organizations or a daily basis. The diagram in the figure illustrates the idea that the KTD is a process, that is, a set of tasks or the stage. But does the data science process differ from the analysis from other disciplines performed? Well, traditional systems of data exploration are fundamentally based on the existence of previous hypotheses or models. Once the hypothesis is formulated, it is analyzed empirically from the information in the available data, and the results obtained are interpreted as a response to the initial hypothesis. This process is an iterative process due to the fact it includes numerous steps in which the user has to make decisions. In this iterative, because it may be necessary to access from any of the above, and interactive because the process is monitored and controlled by the user in a directed way. Well, even though there are different alternatives described in the literature, the process consists of the following stage. The first is the selection of the goals. In this phase, the problem has to be studied and we have to decide what is the goal of the project. It is also desirable to have expectations of success or failure of the project given that these concepts are relative. For example, depending on the problem, a model capable of successfully predicting the percentage of case can be considered a failure. in absolute accuracy, but a great success is the producer used previously only achieve a correct precision of 50% of the cases. With a good approach of the problem, it is easier to discover the data sources and the most suitable on data mining algorithms to be applied. A bad approach to the problem can lead us to wrong results. At this stage, the cost and economics benefits of the project have to be also estimated for the sake of achieving the best solution as possible. In data preprocessing, this stage is the one of the most effort requirements. This phase consists of four main steps, although there could be more interpretations. The, the selection of the data. The internal or external data source are identified and the necessary subset of data is selected, either relation of one databases or text files. Preparation of the data. Once the data to be used have been identified, we must understand the meaning of the attributes to detect integration errors, such as the existence of repeat data with different names or same data with different formats. This problem arises because the data may come from different resources, and not all of them store the same information in the same way. After this process, what we will have in the dataset suitable for the correct function on the remaining phases of the data science process. The transformation of data. Once analyzed the type of problem and the type of variable data, we have to choose the algorithm or a set of algorithms to be applied, as each algorithm requires a different format in the input data. We must transfer the data to adjust the requirements of the selection algorithms. Well, the next is the reduction of data. These techniques can be applied to achieve a reduced representation of the data set, which will much smaller in volume and tries to keep most of the integrity of the original data. The goal is to provide to the later that data mining algorithms with a mechanism to produce the same or almost the same outcomes when it is applied over a reduced data instead of the original data, and the same time as when mining becomes efficient. The next is the construction of the model. It is the main stage because it is where the different data analysis algorithms are applied to the data, which were transformed, prepared, and possibly reduced in the previous stage. During this stage, the patterns present in the data are researched. Depending on the algorithm selected, a different form will be obtained at the output. At this stage, it is possible to use several times the same algorithm, or even we can use different kinds of algorithms. Well, the analysis of results is the moment to interpret and evaluate the results obtained in the previous stage. Different techniques for visualization are often used to display the results obtained. Once the results are visualized, the user must interpret them, and if they don't meet their expectation, could be must reply the algorithms with another parameters, and even to run another algorithms to try to obtain more desirable results. All this makes the process of data science iterative. At this stage, we have to specify how to use the obtained results. They may be either integrated into expert systems or implemented as procedures in a database management system to make decisions. Well, a principal component about this process, and the first is the selection of data. At this stage, it is the first necessary to assess the present problem we want to address. In this, the objects we want to approach with the data science process should be possible. Among other characteristics, we can stress quantifiable, realistic, relevant, multiple objects clearly defined with a list of priorities. The next steps is the data preprocessing. Often in organizations involved in data science projects, there is an excessive rush in the application of powerful analytics techniques for the extraction of hidden knowledge in the data. To use such techniques as and tools, it is necessary to develop one of the key parts of the project and the longest time, which is the phase and preprocessing prior to the algorithm
¿Aló? Hola,
generalized
Angélica,
algorithm.
¿me
¿Sí?
oyes?
Sí,
¿Sí? Sí,
sí,
¿estás hablando falsadamente o la conexión está lenta?
perdón.
No, puedes continuar ahora, es que tu sonido se había ido.
Ah, okay. Maybe the connection. Okay. Well, but why is preprocessing required? Uh, well, this is important because inconsistencies in null values, extreme values, and noise are properties of all data sets and relation in databases. Incomplete data are generated for different reasons. Well, for example, the attributes of interest are not always available or information that you have in erroneous. Other data are not stored because at the time of entering the data, they were found to be of not interest. Noise is uh, again available for different reasons, such as simple problem in data collection, instruments, and personnel. Other times, it is due to transmission mechanisms or simple inconsistencies in code naming and assignment policies. In this way, data cleaning routines will help fill in the null values, identifying outliers and solving inconsistencies. Unclean data creates confusion for the scanning procedure, and often some algorithms include returns for cleaning. These mechanisms are often not robust, so it is preferable to clean them beforehand. Well, uh, continue with the KEEL software suite. KEEL contain all the QDT process. This is a knowledge extraction based on evolutionary learning. It's a free software which empowers to users to assess the behavior of evolutionary learning as soft computing, basic techniques for different kinds of data mining problems like regression, classification, clustering, pattern mining, and so on. The main features of KEEL are: it is present many state-of-the-art methods for different areas of data mining, such as decision trees, fuzzy rules. basic system on rule learning, such as predicting models, preprocessing methods like evolutionary feature and instant selection, among others, and post-processing procedures, evolutionary tuning, or fuzzy rules. It incorporates a statistical library to analyze the results of the algorithm. It comprises a set of statistical tests for analyzing the suitability of the results and for performing parametric and non-parametric comparison among the algorithms. About the data preprocessing, this software includes specialized literature algorithms like data transformation, discretization, instance and feature selection, null filtering, and so forth. The software is aimed to create experiments containing multiple data sets and algorithms to obtain results. Experiments and if the plainly script generated from the user interface for a run in any machine that supports a Java virtual machine. Well, this is the principal image of KEEL software. Well, KEEL consists on the following function blocks. The data management. Well, in this, the data management sections brings together all the operations related to the data sets that are used during the data mining process. Some operations are related to the conversion of the data files from another dataset formats used in data management tools or data mining tools to kill datasets format and vice versa. And it also includes utilities for the visualization of the data. Finally, a procedure to create partitions for a dataset are added in this section. This partition will be used in the experiment section to create the key-fold cross-validational experiments in an easy way. Well, these data management operations related to the datasets. Experiments is to create a data mining experiments. The experiment section is designed to help a user to create a data mining experiment using a graphical interface. This section is the most powerful section included in the tool. It is enabled to the users to apply the implementation of algorithms to any given data set and fulfill a data mining experiments. This procedure allows the users to create all the configuration files for the methods. These files are automatically created by KEEL software suite and is also enabled to users to perform powerful comparisons with a large number of datasets. A large number of algorithms, another useful operation like the application of a statistical test to the results of the experiments or the output of useful data associated to the experiment. For example, the accuracy associated to a data in a classification experiment. This skill section has two main objects. One of had you can use the software as a test and evaluation tool during the development of an algorithm. On the other hand, it is a helpful tool to can be used to compare new developments with standard algorithms already implemented in the KEEL software. The next module it is educational. This offers a real-time view of the evolution of the algorithms. This section tries to be a helpful tool in a teaching environment. The educational section offers a real-time view of the evolution of the algorithms, allowing some students or users to use this information in order to learn how to adjust their parameters. In this sense, the educational mode is a simplified version of the main key research suite, where only the more relevant techniques are available. The next is modules. In this section, software for specific tasks associated to the data meaning are present. This part includes need modules extending the functionalities of KEEL, like imbalance learning. This procedure in this module features several algorithms specifically designed for imbalance classification. The graphical interface gives the user access to a specific set of problems. Algorithms and evaluation procedures covering the state of the art in imbalance classification. When we talk about imbalance learning, the problem is when a data set, when we have two classes, we can say that is an imbalanced data when one of the class is more representative than the other. Well, the next module it is non-parametric statistical analysis. This module provides the user with several non-parametric statistical procedures for parameters like Wilcoxon test and multiple comparison like Friedman quad a contrast estimation, together with several post-hoc procedures for advanced verification of results. Given in raw format, furthermore, this module outputs all the results of the analysis in LaTeX format, easy the inclusion of the reports obtaining any experimental report. Well, the next in this is the semi-supervised learning. This module, similar to the balanced learning module, is devoted to the creation and design of experiments related to semi-supervised learning. It features an interface similar to the experiment section featuring related datasets and methods which are useful in this scenario. The last one is multiple instance learning. The multiple instance learning module, which which follows the same scheme as the imbalanced and semi-supervised learning modules allows the user to create and prepare experiment for multi-instance learning. It features a graphical interface similar to the experiment section that gives access to specify multiple instance dataset and algorithms designed to tackle this problem. The last one is the help in which we can have the documentation. Well, to getting started with the interface of KEEL, it depends your operating system. For example, in my case, I have macOS. Well, if you have Linux, is a similar way. And if you have Windows, uh, maybe can be more easy to search the files where the kill software is. First, note that the Java version required is the version 7. This is need to be installed on your system for this workshop. Depending on your computing platforms, you may have to download and install it separately. In order to launch the KEEL software suite, you just have to execute the graph interkill.jar file. This file is in your path. When you unzip the software, the path of this or the content of this file are kill, a file with kill, a file with experimentos, another file with kill, and finally the dist. In dist, the graph interkill, there are a file, a jar file named graph interkill. Then navigate into this folder and run the program by simply execute the graph interkill jar file. There are two different procedures to execute this file. The first one, the first option, if you have a Windows system, right-click on the chart icon by using the navigation utility of the operating system. But if you have Linux or macOS, you execute the following command in the shell. This is the sorry. This is the command that is necessary to execute in the shell when you use Linux or macOS. Make sure you have properly set up the Java path. Well, we continue with the menu and toolbar. When you execute this command, the first image that you can see is like that. But when you use one of these modules, the interface are like this image. For example, when you click on experiments or educational modules, you can find a similar and primordial interface like that. When you click on the file section, there is a submenu when you can find new experiments in which create a new experiment. Load experiments which open an existing experiment. In the Open dialog box, select a file and click Open Experiments. Files usually are saved in an Excel format. Save experiments saves the current experiments to an Excel file, and is the first time that the experiment is saved. You will be asked about destination path. The last is exit. This close the experiment design tool. If the experiment has not been saved yet, you can do it in this moment. The third menu is the view. On view, you can see a status bar shows hides the status bar at the bottom of the windows. Initially, in this It is activity. The next is the grid, shows or hits. The alignment grid, it helps the users to make easy the alignment of the elements inserted in the trough area. Initially, it is inactive. The next is help panel. This shows or hides the help panel initially in this active. Data sets and algorithms shows and hits the panel containing the data algorithms. Initially, it is active. When you click on Edit menu, you can see undo with this option that you can undo some actions. Redo with this option, you can redo some undone action. And finally, select, which allow us to select one or more elements in the draw area. This is the draw area. Okay. Well, sorry. The next section in the interface is the toolbar. When you start some experiments, the toolbar is enabled. But when you start an experiment, the toolbar has to be colored with the icons in which we can find insert data flow, allows connecting algorithms, outputs, or data sets on the inputs of another algorithms, creating a data flow that will be run later. This option is also available from the left bar via the button. Import an algorithm key pack. Sorry, this is import an algorithm key pack. In order to insert user method, select in option and explore the path to choose the method. Well, when you use the toolbar, we can the new experiments. When you start a new experiment, we can use the the different uh, algorithms and the data sets. It's important considered when you execute some experiments, we need to consider the Java heap size. This indicates the number of megabytes that will be allocated in each execution of the algorithm's default value. For a note that on some tools are not available. This situation changes when you hit an example. Well, we can load an experiment when we have an experiment saved in our computer. We can load this. The save experiment is when we finish an experiment, we can save it with a name, and this have a zip experiment that we need to run in another shell. Under render, delete, and select, it depends when we need to float the data mining process. The contents sh- the content show its data sets algorithms, and we can take a screenshot of the experiments with this. When we have the data meaning flow in this part, we can take a screenshot to share with someone. When we use the status bar that is above, it's a simple way to provide the users useful information during the generation of experiment. It dislocates at the bottom of the window. Here it will appear information about the action being carried out, helping the users to understand the meaning of each command or button. When we use import our own data, the installation of new datasets into the application can be done using the data management module on the experiments module. These modules can cover data from several formats. In an example, we can use these different formats. Please keep this link because later we use it to download a data set to import this data with the KEEL data and use it in an experiment. Well, in what follows, we show us in a simple an example of use, enumerating the steps to be done. From this first screen, this, we need to click. Uh, I I shared another screen. Well, can you see the shell?
Angélica, Angélica,
Yes, yes, Kim.
solo un rato que creo que sí, a ver. No, intenta subir otra vez. Inténtalo subir otra vez, porque aquí no está más.
Sorry. Can you see the shell?
¿Puedes enviar otra vez, subir tu presentación otra vez a la plataforma esta?
Okay.
Passa pessoal ali, por favor, lá de cima ali. Todavía no está para mí.
Mm, ¿Listo?
Ahora sí.
Ok, ok. Well, this is the data import. In this screen, we can use import partitions uh, in which select this option if we have previously performed partition of a data set in other formats, and if we can't, to import them to KEEL format. This option allows the selection of a set of training and test files separately. And the next option is the this option can be used about uh, different types of files.
Obrigada.
The data export, we use data exports to data exports allows us to transfer the data set in KEEL format to desired format like an Excel, an XL, uh, TXT, and, and a table, another. Uh, the next is the file formats. Well, the file formats, there are different formats of data that can be used to work with the KEEL software suite. Like in this chart, we will show the different available formats that we can use to import and export data, like TXT and Excel, a WCAG data file format, and the proper data file of the KEEL software. The CVS data file format, this file is a command separate values. This is one of the is one implementation of the limited text file which uses a comma to separate values. This kind of format is very simple and is supported by almost all spreadsheets and databases management systems. The characteristics associated to this file are following. The first record in a CSV file may be a header record containing name of the columns. Each record in a file can have less files than the number of header columns. In this case, empty values are considered missing values. Each row must have the same number of files separated by commas. Two adjacent commas or a comma at the beginning or at end of the line, space characters, indicates new values. Leading and trailing space characters against the comma file separators are ignored. Each record is one line terminated by new line character or a carry return. Black line will be ignored. Fields that contain double quote characters must be surrendered by double quotes, and each one of the embedded double quotes must be represented by a pair of consecutive double quotes. Files with leading or trailing space or commas must be delimited with double-quoted characters. When we use a TXT file, it's a simple text data that allows tabular data to be exchanged between applications with a different internal format. Values separated by tabs have been unofficially registered as a meme-type multipurpose Internet mail expectation under the name text tab separate values. A file in TXT format consists of lines. Each line contains files separated from another by a tab character, a horizontal tab, or a code control 9 in ASCII. Fields can be any string of characters, excluding tabs. However, tabs usually don't appear in data items that you wish to tabulate, so this is seldom a restrict. There are various other formats which are very similar to command separate values, which use the command as separate. Command space and other characters often used as separators in such format appear rather often in data to be tabulated. An empty value is displayed as an empty file between tabs. The next format is a kind of format, this the C4.5 file format can also be encoded according a special kind of format. This format consists of two files. One of one of them is a name file with the extension names. The other one is a data file with the extension data. The characteristics associated to the names file are in this contains a series of entries that describe the classes, attributes, and values of the dataset. Each record is terminated with a point, but the point can be omitted. It will have been the last character on a line. Each name consists of a string of characters without commas, quotes, or colons. A name can contain a point, but this point must be followed with a white space. This kind of files we can choose in we can find it in some websites when we can use open data sets. In the next section, the section of tomorrow, we can use this web page to download a kind of this file.
Ai, põe elas nesse parte aqui no fundo aqui, tem os pratinhos.
The other
Ah,
file
ela não
is
tá
WEC.
na mesa ali.
WEC data file format
Deixa eu passar o copo.
is
Ah, obrigada.
similar that KEEL data file. For example, this is a KEEL data file that is similar to WEC because the first lines of the file have the attributes, the name of the attributes and this description. When you find in a line and add data. Follow that the the data set can be finite. Well, if you don't know what is Wika, Wika is a Wikato environment for knowledge analysis. It's a suite of machine learning software written like KEEL in Java, developed at the University of Waikato, New Zealand. And Wika is a free software available under the general public license and is also a popular software for machine learning and data analysis. The key data file can be imported or exported in key data file format. This format is used in key experiments and is associated operation kill data files and represent a plain ASCII text file named with the DAT extension. The visualization options provide graphical information about exciting kill dataset. There are different options related to graphical information. Sorry, visualize data. In this section, uh, KEEL provides graphical information about exciting KEEL datasets. There are different options related to this graphical information, where an user can select to view the content of the data, specific information about the attributes, or to compare two attributes using characters. If you can see, we can load the data and we can see the content of the file. First of all, a user or you must select the path of source data set in KEEL format that is going to be visualized in this figure. When the file is loaded, different information about the data is shown according to this option selected. In, in Data Set View, if a user selects to visualize the dataset information, the content of data selected will be shown in plain text format, like this. The data cannot be modified. The user can only visualize. When, when we click on Attribute Information, in this option, a user can obtain detailed information about the attributes defined in the dataset. The information showed in this attribute type, like integer, real, or nominal attributes, and whether the attribute is input or output. Below the attribute information, there are two additional areas that provide further information about the selected attribute with the attribute list. On the left side, textual information about the attribute we will show. This option depends on the attribute type. Only its possible values are displayed. On the right side, graphical information about the selection attribute is provided. Specifically, the distribution of the attribute's values is shown from a chart like this. This, this shows this information is organized for a real attribute, which information is provided for a nominal attribute kill. The next is Chart 2D. This option enables a user to contrast a pair of different attributes. In order to do so, an user has to select the two attributes that are going to be compared. There are two drop lists to select the two attributes that are going to be contrasted, this and that. Each one of these lists containing all attributes of data sets. In the exercise, we can click on that and we can see all our attributes or our data set. When the attributes are selected, a user has to click on View Chart. This button antenna graphical depict the value of this attribute is shown. This is if the generated chart is expected to be introduced in another document, an user should use the button to convert to PNG or convert to a PDF file. This convert, it depends what you can, if an image or a file. This chart is the final output of the PDF file or the PNG file. Well, when we use the edit data feature allows you to edit any existing KEEL dataset in order to add new attributes, to delete others, to correct some errors within the data, and so on. We can see that the main window of the edit menu, first of all, a user must select the path of source data in KEEL format that is going to be edited. When the file is loaded, in content appears below the load datasets option. Organize it in a table in the data area. The modification over this dataset can be performed both over the instance and over the variables in the following. We will address how to an user can alter the values in a dataset from both approach.
No.
When we edit,
Dez-
when we have the data edition, this option enables a user to add a new instance, delete an existing instance, or modify any of the value instance in the data. We can add, delete, it depends we click on the instance. We can modify when we click on the instance. Modify the cell content. A user that wants to modify the cell content has to click on the cell that wants to change. Then the user has to write a new value, and if it's valid, the cell content is modified. Otherwise, an error dialog is shown. When we delete an instance, a user, or if you that wants to delete an instance, has to click on any of the cells area associated with the instance route that a user wants to delete. Then a delete instance button is activity. When a user clicks on it, the full instance will be deleted, and a new instance. If we click a new instance, a user or you, if you want to add a new instance, has to click on Add Instance button, which a new will then add a new instance. If a cell was previously selected, the new instance is added on top of the instance whose cell was selected. If no cell was selected, a new instance is added at the bottom of the table. The new instance will have empty values, and the different values can be filled out clicking on the different cells. This is a manually adding. When we use variable edition, in this option, different modification on the variables of the selected dataset can be carried out. In order to do, an user has to interact with the table to display the data set information and with its associated buttons. The operation that can be performed are add new variables. An user that wants to add new variables has to click in Add Variables button at- in this part. Then a new row is added at the bottom and the table which can file it with the values that can an user consider appropriate. Delete a variable. An user or you, if you want to delete a variable that, that has to first select the variable that is going to be erased and then click on the delete variable button. This is the delete variable button. You need to click in one of them to delete the variable. Another things that we can do it with the data set is change the range of the values. If you want to change the range, first of all, you have to select a real or an integer variable. If the variable selected is integer or real, the user or you can modify its range values and click on change range. This button to change the information. When we change nominal values, that is different from integer or real values. If you can change that values, you have to select a nominal variable. If the variable selected is nominal, a user can add or remove the values allowed for that variable using the list or delete and add buttons. An example of nominal values are like colors. We can use red, blue, yellow, etc. When we change attribute type, an user or you, if you want to change the variable type, has to click on the cell that contains information about the attribute and the type. That is the cell whose row represents the variable that is going to be changed, and the type column. Then the user can modify the variable type using the drop-up list and then show specify any other type of variables. And the last one is change attribute function. An, an user that wants to change the attribute function has to click to the cell that contains information about the attribute and the function. That is the cell whose row represents the variable that is going to be changing and the input-output column. Then you can modify the variable function using the drop-down list that is shown specify if it is an input or output attribute. When all the change to data had been applied, a user can save to a file. Click on Save button. This is a Save button. The next section is the experiment design. The experiment design section goal is to allow a user to create the desired experiment using a graphical interface like this. To do so, you is expected to use available datasets and algorithms to generate a file containing a folder structure with all the necessary files needed to run the design experiment, and this processing unit selected by the user. In this way, an user only needs to select the input data set, the algorithms that want are going to be tested, and the connection that define the process flow that needs to be run. It's possible to concatenate methods, insert statistical tests, and so on. Moreover, the tools allows an easy configuration to the parameters associated to each method. They can be selected using the graphical interface without external configuration files. This part of KEEL has two main objectives. One of the hand, an user can use the software as a test and evaluation tool during the development of an algorithm. On the other hand, it is also a good option in order to compare new developments when standard algorithms are already implemented, available in the KEEL software suite. In this to configure configuration of experiments, we select the type of experiments. We select in configuration experiments, sorry, the main window of the experiments module appears. First, it's necessary to select the type of experiments and the type of partitions to employ it in this part. It depends your experimentation. The types of partition available are the careful cross-validation. In this part, we can put the number of the partitions. The most common is used the 5 per 2 cross-validation. This implies that the whole data set can be divided in 5 parts. The 5 parts, 2 are used by test. Currently, The KEEL experiment models offers the classifications, well, the classification, the regression, and unsupervised learning and subgroup discover algorithms. The next is the selection of data sets. In this part, if we have our own data set can be appeared in this, but KEEL have some data set pre-configured to use it. In this panel shows the available data set for the current experiments. This content will depend on the type of experiments already selected. When you use the import button in this part, allows to importing an exciting data set into the KEEL environment, ready to be selected for the current experiment. By clicking on it, the main window of the data import tool will be appeared. This process is important. Import a new dataset. Can it is described in the data management module. The next is the experiment graph. In the experiment graph, shows the components of the current experiment and describe the relation between them. You can use the left menu to import data, to select the algorithms in which we can view the dataset, modify the dataset of the experiments, the preprocessing module. In this, we preprocess over the initial datasets, the standard methods, the post-processing methods, and the statistical tests and visualization modules and connection. In datasets, this module let us edit the current dataset select for the experiments. And as in the select dataset panel, user can or you can add or delete datasets to the experiments. This is important because it depends on the data that we have to use to preprocessing method. This part, in this part, it is also possible to add or complete a set of scaffold cross-validation files by selecting the adequate number of files and preprocessing the button Add scaffold. After that, we need to use the preprocessing methods. In preprocessing methods include several algorithms like data complexity. It can compute 12 different indicators of the source and complexity of the considered dataset. The discretization includes methods for converting real or numeric data into nominal data. Feature selection, like standard evolutionary methods, include methods to select features of the data. Training set selection includes methods to select instances of the data. Missing values includes methods to assess data containing missing values. And transformation. These include methods for transforming the format of data, nominal to binary, decimal scaling, and so on. These methods are relational with the KDD process. In fact, is the preprocessing step. The next is the standard methods. In these methods, it depends when you use a classification or regression methods. This category includes the data mining methods included in the KEEL software suite. We can find association rules. This method for extracting association rules from data. Associative classification. These kind of algorithms are about meaning classification rules following an associative rules meaning scheme. We can find clustering algorithms, Krebs rules, decision trees, fuzzy rule learning, hybrid instance-based learning. These methods using hyperrectangles, combination of rule induction and instance-based learning to extract knowledge from data. Well, these kind of methods extract the knowledge from the data, and this depends if classification or regression. We can find neural networks, standard evolutionary, prototype generation, and prototype selection, statistical classifiers, statistical regression, and support vector machines. The next module in this an experiment design, we can find the post-processing methods. In post-processing methods includes methods like future rule post-processing. These methods performing a post-processes phase over the results of a future rule extraction method. The next is the statistical test. This category includes several statistical methods available to contrast experiments performed with the KEEL software suite. We can include tests for classification, statistical procedures for contrasting the results of classification and experiments, and we use regression. We use the test for regression to contrast the results of regression experiments. The, we can visualization modules in this category includes several visualization modes developed to analyze and summarize the results achieved in the experiments, like short results, models for classification, or for regression. If we have multiple algorithms, we can use the multiple results classification or regression. And fingrams, in this in case of UC, this module generates the requirement configuration file to use a standard alone open source software to which creates a fingrams. Finally, the connection. This insert a connection that allow finish the design of the experiment by connecting the included modules with flows will represent the data flow in the experiment. We can use both of inputs or outputs of the modules. Insert connection to make a connection. Select this button and put then to create a connection. I think we have on time. Uh, I don't know.
Eh,
Uh,
sí, Angélica, si quieres, sí, podemos más 5 minutos si necesitas o mañana continúo, como quieras.
¿Continuamos mañana?
¿Mañana?
Sí,
Vale, perfecto. Sí, pues nada, muchas gracias entonces. Nos vemos mañana.
gracias. Hasta
Y sin
mañana.
retraso mañana. Por ahora ya estamos optimizado hemos optimizado la cosa.
Ok,
Pues muchas gracias y hasta mañana. Tenga un lindo
gracias.
día. Hasta luego.
Gracias. Hasta luego.
Hasta luego.
Hasta luego.
Adiós, hasta luego.
Bye.
Pessoal, o coffee já vai ser servido, tá? É ali, tá bom?